Record. What's recording? I hope it goes to the cloud. Oh, okay, sorry, YouTube live stream. All right. Screen share, screen. Do. What are you guys' favorite animal? I heard cats. Why do you like cats? Mm. What about y'all? Do you have a cat favorite animal?
Favorite animal? I like rhinos.
Rhinos. Why do you like rhinos?
I did research on it. It's like seven for like a little project. I like it.
You know, I actually had a little project in like second, third grade where I was like I had to dress up like a lion. I like lions. Lions are my favorite because they're kings. What about you guys? Do you guys have any animals? Favorite animals? Why do you like the red panda? Have you seen that one Pixar movie? It's like Turning Red. It's a very interesting movie. Yeah. All right, I just wanted to disarm you guys. All right, let's see. Where is the slides? These are the slides. So with this module, it's two parts. So yeah, this module is kind of a continuation of equilibrium concepts. We're gonna have a lot of things to talk about because we missed fun day, but that's okay. It's not really that big of a thing. Um, but yeah, this is just kind of a continuation with equilibrium. So a lot of the questions about calculating things with equilibrium also can be applied to acid bases. It's a little, yeah, there's definitely gonna be other like contents or applications within acid bases that contain equilibrium concepts that are unique to acid bases. But I'm recording, yeah? All right, I'm recording. So yeah, it will be pretty, it's just gonna be a continuation. So, but we're gonna have to learn the concepts. The concepts are really important, especially for the MCAT and also for the exam. And I think that there's like two different kinds of people. There are people that are good with the concepts and then they're not great at the math. And that's like something we can work on too. And then there's also people that are good with the math and not great with the concepts. And like, you gotta find a good like way to mediate your weaknesses basically. So like, as we get into acid bases, as we continue like talking about equilibrium in general, like be honest with yourself. Like, are you guys good with concepts or are you good with math? And like being honest with yourself and also with me and help me tailor these sessions to y'all and help you guys with all of that. But that being said, I will post like a YouTube video of me going over all the math kind of problems that you can encounter. I made this video like 2 years ago when I was in my first year. So it goes over literally, it's like an hour long, but it goes over all like the math questions that you'll encounter. But that being said as well, this is part one of the module. I'm not gonna post a worksheet until we're done with both parts, because it just makes sense to only have one worksheet for all of it. So yeah, hi professor. So yeah, so there are some definitions with Brown-Sillary with acid bases, right? So we've traditionally learned what the Arrhenius definition is. You do need to know the name of that, Arrhenius, right? And Arrhenius is like the basic definition, right? Acid bases, acids produce H plus, bases produce hydroxide. Brown-Sillary is more of the, I guess, it's actually more of like a chemical kind of, I guess like a reaction, like how reactions kind of work. You'll see how it works, how it applies later, but this definition, in my opinion, is a lot more, I guess like deeper, I think, you know, proton donor and proton acceptor, right? So that like kind of implies or it infers like they do in a reaction, right? Whereas the first one just like says like a characteristic of it, right? But there's two different things, basically. That's what I'm trying to say. So like, for instance, for like, let's say ammonia, right? Ammonia is not Arrhenius base, right? Ammonia, though, is a Bronsted-Lary base. And why I'm saying that is because when it reacts with water, it will produce ammonium plus OH minus. And this is typically because of that lone pair on ammonia, right? So this is like a little bit of a definition, right? This is a Bronsted-Lary base, but it's not an Arrhenius base because ammonia on its own is not gonna produce hydroxide, right? But something like sodium hydroxide, right? That's an Arrhenius base and a Bronsted-Lary base. And that's because, like, let's say it's reacting with like HCl, it's the hydroxide is going to take that H plus from HCl and it's going to make water and then they're going to make the salts, right? So like NaOH is our Arrhenius base and a Bronsted-Lary base. But NH3 is only a Bronsted-Lary base because of the definitions we have. So I'm pointing this out because there's probably going to be a question regarding which of the following is a Bronsted-Lary base, but not a like Arrhenius base, right? So this is like a concept that's pretty important. And you definitely need to know it for the MCAT as well. And then this is like the whole thing with like Bronsted-Lary acid bases, right? You have to be able to identify the conjugate acid base pairs. And the way to do that is if you have an acid, right? Let's say you have HCl, the conjugate base is going to, so like there's gonna be an acid and then it's conjugate base. So the conjugate is on the other side of the reaction, and this will have no like one less hydrogen because it's a conjugate base, right? Acid conjugate base. With base, it's gonna have a conjugate acid, right? So that means that's gonna have an extra hydrogen, right? When you talk about Bronsted-Lary acid base. So it's like acid conjugate base, base conjugate acid. All right. So that's pretty much how you do that. There's definitely going to be a question on your exam about that. So yeah, you guys can try out these questions. Yeah. So just take some time, take a minute to do that. All right, you guys chilling? So yeah, this is the answer, right? So notice how I like wrote out these lines. You can do this on the exam, right? I have these lines, right? And so always there's going to be that relationship where the acid is going to have one less hydrogen as a conjugate base, right? So the conjugate base is going to have one less hydrogen than the original acid. The base is going to have one more hydrogen than the conjugate acid is going to have one more hydrogen than the base, right? It's like, it's hard to like say it out loud, but as you keep practicing, it's gonna be good. All right, so yeah, that's good. This is just a good concept to know. Amphoteric, it means that it can behave as an acid or base. An example of this is water, right? Water is amphoteric. Water, when it reacts with water, it can produce H3O plus and OH minus. So, or you could just write it as 2 water, right? Water is very amphoteric, right? So it can be acid or base. That's why when we see it react with HCl and ammonia, right, it produces either hydroxide or hydronium. Okay. And then we talk about this. This is the auto ionization of this of water. And that gives you this value for Kw. So this value is very important. You definitely need to know it for the MCAT and also for your exam. But yeah, the whole thing is at 25 degrees Celsius, that's when Kw equals that. In your body's not 25 degrees Celsius, right? So it's like 37 degrees Celsius. So this Kw is going to be different, probably going to be a little bit more. But that's why your body's a little bit different than this Kw. That's why you can't assume whatever, unless they give you the temperature or they tell you whatever, or they don't tell you enough information to like figure out they would have to tell you something if the Kw mattered, if it was a different Kw. But don't stress about that. And then yeah, this is kind of a intuitive thing, but we learned this probably in high school chemistry that in basic solutions, right, there's going to be more hydroxide than hydronium. Acidic, there's more like hydronium than hydroxide, and neutral is equal. All right, just pointing that out. But yeah, all right, we're moving on. So pH, right, POH. Okay, this was a question you were talking about, Jennifer, where they gave you a different Kw, right? And this is because it's in the body. So that's why Kw is different. But yeah, let's try to do this. Try to do this question.
Like this, one of this, and then right? So what I'll do is I'll put the numerator on top. So this. Here. Oh gosh. And so that's the next one. Right, so next up, which is. Yeah. Great, man. This is like, and then minus that. So you get, yeah. Oh gosh, I remember all of this. This is so useless. I'm sorry. Alternation of generation. Oh gosh. I remember I had to do a whole lab report on it. Dude, it's so stupid. I'm sorry. I'm so sorry.
Yeah, we have like 3 labs per week or something.
Yeah, it's like,
You have to remember all things.
yeah, for that. You feel lab quiz? Yeah. Oh my gosh, you guys are really going through it. I did not have lab quiz for my bio. Oh gosh. I feel bad. I'm sorry. This is why it's very important to learn who are the right professors to take next semester. Oh, yeah, that's like the question to ask, right? So, yeah, I mean, you don't really have a lot of options. I think for Orgo, you have to take learning curve for your lecture. And then genetics, you have to take the full blown physio. I recommend Calvo. I know that you guys might be a little bit iffy about her, but she's probably the better professor. I don't know who the other one would be. Yeah.
Physics, we don't have professors.
Yeah, they're not listening. They never listen.
So how do we know?
That's the problem. You don't. And frankly, this is probably the first, this is one of the first years where it's like very like out, like no one knows what's gonna happen. Because I think like there's like a new, like one of the physics professors died. So like, you know, in the beginning of the semester, one of the physics professors died and then they had to like hire a new one for the BSU. So like a lot of them have this like new professors, but like, I think he was working at LaGuardia College. He's like kind of black. No, that's not him. He's been here for a long time, but he's more of a lab teacher. No one, he doesn't. Yeah, it's kind of bad. So I don't really know what the lecture teacher would like. To be honestly, I think from definitely Rex. I think Rex would be Tuesday, Thursday.
It's on later, but like, maybe we had like one to.
Yeah, that's for Monday, Wednesday. Yeah,
You don't have a choice, right? It's gonna come out like after we.
yeah, I mean, there's no like specific BSDO specific physical class.
Just like whatever time we choose, just.
Yeah. I took, so one thing is you can look at the times of the labs and know what to take. So I remember 8 a.m. was Benjamin Wayne. So I liked him, he was very helpful. And then I think Tuesday late is Wayman Sound. And she's really good too. But yeah, that's all I can say about physics. Yeah, for orbital labs, the Friday labs are always better. I know it's annoying, you probably don't want to have the Friday lab, but you don't really have a choice with 4 labs. So,
Do you have any applications for the, I don't know if it's biolab or
physio lab,
the biolab that we were. Like some of them either just have like overviews.
so with genetics lab, none of the genetics lab teachers really matter because of how Google runs the lab. So you don't need to worry
I think
about it.
Copeland has its own lab.
Yeah.
too, so it doesn't matter.
Yeah, it doesn't really matter, it's all completion, but you take your exams during lab. For genetics, so. Keep that in mind, right, there's a Thursday lab and a Friday lab. Want to do the test first, or you want to do the test second, you know, like. Kind of the whole thing with that. So. Friday lab is probably better again. Physio, all the lab stuff, so that's why Cal is really important for physio, because she's very understanding of the fact that all the physio lab teachers suck. So, can't help with that. I would, you don't need to do a physio like Friday lab, because I think that the Friday physio lab teachers not that great.
They're both online. They have both.
Yeah, the teachers there, from what people showed me, I don't know. So, yeah. Yeah, but I mean, it's asynchronous, right, so it's not, it shouldn't be too bad.
Oh yeah, how does that work? You're just supposed to work.
Yeah, so every week you post the work and then just do the work.
Oh, it's not like lecture recording.
No. So, like, it's all on your time, you know, you have to make sure you're diligent with that. Yeah. But, yeah, so half, but I think like it's. You guys got this, okay? Not gonna be bad about it. I mean, I feel like this semester is probably worse for you guys, honestly. Like, you guys have so many quizzes and stuff, and it's like I didn't have this many quizzes in my first year, like I have anatomy. And it also had a good bio lab teacher. Like I was kind of not sure so much. You guys got this, okay? If you guys can get through this semester, like next semester will be fine. Okay?
Yeah, with the genetics lectures, like you don't need to go to the lectures. Because he recorded all the lectures. He always says it's helpful to go to the lectures. But it's not, it's okay. A lot of people were like, at the end of the semester, like, there was only like 10 people in the lecture. Yeah, and it's like the big lecture hall. You know, it's like the Harry Shearer lecture. Yeah. But you guys got this, okay?
So he doesn't take attendance?
He does take attendance, but it's a QR code. So you can send it to whoever you would like. So, yeah. Oh, I should. Okay. All right. Anyways, all right, let me show you guys the answers. So, yeah, there's multiple ways of going about this question because there's so many different ways you could do it. You could subtract whatever, you could figure out the hydroxide concentration first, you could do whatever you would like. But you know, whatever you choose to do, just try to do it as fast as you can. Because these questions, like he's gonna give you less questions for this exam, right? And so with that in mind, it's important that you like don't just like take your time on those questions, but like learn to like do those questions fast, all right? I know a lot of people are like, oh, I might make mistakes and stuff, but if you're confident and you practice enough, like you're not going to make a mistake. That's just how you practice, right? So practice doing these things because these things are going to be so repetitive. Negative log of boom, right? Or 10 to the negative something, right? Or like 14 minus like you're always going to be doing this for actual basis, so get used to it and build that confidence. Okay. Okie dokie. Does anyone want me to like go over anything here or no? You guys chilling? Okay. So this is just acid base, strong acid bases. Yeah. You want to try to do this question? We'll give you a couple minutes to do this one. This one question.
That's the shape of your child. Made of a little bit.
Why did you why? There's a name on my product.
Yeah, because it got just like a code shots.
Oh, yeah. Okay, I'm calling you something.
Okay.
Excellent.
All right, you guys probably to finish this up, right? Okay, so it's important to know that with strong acids is 1 to 1. You'll see your weak acids is not like that, so you can figure out the pH and then you can figure out the pOH, right? A lot of people might get confused because it's like pOH acid, like how do I do that? But it's really not that difficult when you are comfortable with these kind of questions. So again, there's not a lot of original, like there's only a plethora of like kinds of questions you could ask. Like he might give you some background on hydrobromic acid, but it's still fluff, right? Like these are like questions that he could ask, and it's like not that hard to like change it up that much, or it's pretty hard to like change up the kind of question to do that. But all right, now we're talking about acid strength and weak acids, right? So all this is saying is that with strong acids, right, you're going to produce like products pretty much like 1 to 1. But with weak acids, there's probably going to be more like reactants than products, right? And that's why it's an equilibrium with this slide to the left, right? So an example is like acetic acid. Acetic acid is CH3COOH, when it reacts to water, it is mostly as an acetic, like it remains acetic acid. But there's parts of it that become CH3, COO minus, and plus hydronium, right? So this is just an example of a weak acid. The Ka is probably like 1.0 times 10 to the negative 5 or something, right? So that means that there's a lot more reactants than products. And so these are just some strong acids and bases you should be familiar with. I guess a good rule of thumb for the strong bases is that a lot of the strong bases are all ionic compounds. So you can just make sure you remember that. And then, yeah, strong acids are the things you have to remember. I think one thing I could say is with these, any compound that has a lot of oxygens will be considered strong, right? So like for instance, like nitrate, right? Nitrate is a strong acid, but nitrous acid is a weak acid, right? You got like chromic acid, is that how you say it? I guess chromic acid. Yeah, it's chromic acid, but HCO2, right, would be a weaker acid. That's hypochlorous acid. Or no, this is chlorous acid. Yeah, this is just chlorous acid. Hypochlorous acid would be HCO, right? So I'm just showing that there's a relationship with the oxygens. The less oxygens you have, the weaker it's going to be, right? So that's what I'm trying to point out. There was a question on my exam, I think, where it was like rank the following acids. It's like probably the first question, and it was like HiO4, HiO2, HiO3, and then HiO, right? So like if you just remember the oxygen rule that I'm telling you that, yeah, this was a question I think I had or last year had. So yeah. And then yeah, weak acids. The way to rank these things is you have to have the Ka, right? You can't just compare the weak acids with each other. You're not at that level of comparing the structure or anything and trying to figure out which one's weak or not. You need to have the Ka. This is just something you will be asked to figure out as well. Percent association. It's basically just the amount of hydronium produced from the initial concentration of the drug, if that makes sense. So for this, let's say you are producing, actually, I probably have a question for it, but yeah, the initial concentration of the acid, and then this is like what is produced as a result of the equilibrium. Okay? Is there any questions about that? Anything like that? Do you have any questions about this concept here and why there's a light bulb here? You guys understand it from the lab? Okay, all right. Okie dokie. So this is just writing whatever stuff. Mm, 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 mm. Okay, okay, okay. All right, let's try to do this question. Let's try to do this. At the point, study smart. Don't study harsh. Whatever. When it comes to anatomy, when it comes to chem, when it comes to bio, your resources what you need.
No. It's an arrow?
Yeah.
That's crazy. Oh, that's cool. You just cross multiply right the denominator, right? So it's really hard to just put this into the calculator and this into the calculator because this is like a really crazy like line, right? So I know which question this is from. Someone asked me how to do it. This is so for the top one, I'm just gonna do x squared. You don't need to put the brackets into that, but and on the bottom, on the y2, I'm gonna do 9.2 times 10 to the negative 4. Times, right?
Oh, oh my God, words.
Times .52, put in that one in parentheses. Minus x. Okay, so you see how I put this in parentheses, right? If you didn't put it in parentheses, it'd be like here. Yeah. Right, but this is the correct thing. Just making sure it's good. So now, if you look at the graph, right, it's gonna be something, right? So I'm gonna put second count, and then put it intersect. Okay, and then you just get this. And so. So you do negative log of x. See how, so now, like, now you know it, right? I want you to try to do what I just did. Here, right? Try to do it in practice. As you keep doing it, you're gonna get faster and faster, and that's gonna be like a one-minute question. Yes, he asked me about calculators, because I think like half the battle is literally plugging everything into the calculator. Like you could have the right math, but then if you put one wrong zero, it's all wrong. And it's multiple choice exam, so you know, there's no partial credit. So, please let me know if you need help with the calculator. I have the tricks and everything.
I think the last exam was, let's see how long this exam. Okay, this exam was 40 questions. That's not bad. Wait, no, is this? Yeah. Okay. Yeah. All right. All right, you guys chilling with this? All right. So, yeah, I'm just gonna go through it quickly because this is a little bit interesting, right? We have an unknown acid, right? And so for this, if it's an unknown acid, like it's okay if you don't know what the acid is, all right? You guys need to be confident in your ability to like do acid bases, especially if it says it's unknown. So I'm just gonna put like HA as an acid there, right? And I'm gonna make it react with water. And we're trying to figure out the percent dissociation. So that means we need to figure out the hydronium concentration. So that's why I decided to react it with water. And so I'm gonna put something like this, right? And so we're just going to do an ice chart. And if you guys have noticed, right, every single like time you're like trying to figure out the pH of like a weak acid, right? It's kind of the same format of the question where it's like you're gonna do minus X, you're gonna do plus X, right? Oh. And then it's going to be like X, and then 0.520 minus X, right? I don't know if you guys have noticed, like it's pretty much like the same kind of format for all these different kinds of weak acid, find the pH questions. So that's why I'm saying that these questions aren't that original because there's not a lot of like new things you could possibly do with this. But anyways, now I'm setting this up. And a lot of people have been asking like how to set this up in the calculator. So y1, I'm gonna put like x squared, and then y2 is going to be parentheses 1.02 or 1.20 times 10 to the negative 4, and then 0.520 minus x. And then when you do that, you get your answer. And that answer is the concentration of hydronium. If you press, when you find the intersection point, if you press X, you'll get the X value, right? So you could put X divided by 0.520 times 100, and then that should give you the answer. All right, I don't know what X is, but X is this value. All right. But yeah, X gives you the exact number. This is not the exact number. This is a rounded number. And I also asked to find the pH, so negative log of X. Okay? Okay, sounds good. Weak bases are the same kind of thing, except now you're finding hydroxide. So this is a good example of that. All these are quote unquote weak bases in comparison to like the ionic bases that we're talking about. And this is just kind of a homage to like organic chemistry, but if you notice, all these things with like the nitrogens, right? Like they all are bases, right? And this is not like anything like, I guess, unique with nitrogen. Like the structure of compounds that like nitrogen produces like kind of base like compounds, right? And that's because of this lone pair, right? This lone pair allows it to act as a Bronsted-Lary base because it's able to accept a hydrogen, if that makes sense. So if you think about like ammonium versus ammonia, right? That's like the base example, right? If it was just like ammonia here, right? It's got the lone pair, right? And then all these are basically just like, I guess, different analogs of quote unquote ammonia, if that makes sense. But yeah, I'm just pointing out the structure. There was a question where it was like, it gave you peridity, and it was like, which of the, like, how would you describe peridity, right? And like, one of the answers is like Bronsted-Lary base, right? But some people were like, oh, could it be an acid, like a Bronsted-Lary acid? Because it had hydrogens, right? But it's not able to release those hydrogens, right? So that's why it's important to be able to differentiate those things. But yeah, okay. Okay, so let's try to do this one. So now we have the Ka and we have the conjugate base, right? And then we're trying to figure out the pH. So let's try to do this. How to figure out the Kb. That's the Big trick with this one.
Is this from the original question? No, it's not. Yeah, I think I got it like 3 times or something. Because it's like, it goes on the first line, and it goes on the second line, and then asks you, are you sure? And then. Have you seen Invincible? Like, that shit, chill.
Oh, no, I've seen a bunch of clips.
It's like, it says first pair, question mark, second pair.
Okay.
Then it's like, yeah. So you got just- Sometimes, like, you might get some that doesn't really work well with this. so
Yeah, you
can
can design it. Yeah. Sometimes it's like.
Yeah.
Yeah.
That's not good.
That's how we change.
Yeah.
What we just.
Right, so this is now, we didn't talk about, actually, no, we did, we talked about the shots of there's like.
The initial. And then.
So late shots of there's is just like, if you add something to the reaction, like something will shift.
Like this one, you can see them coming.
Right.
Yeah.
But hydrochloric acid produces hydronium, like hydronium, right? So if you're producing hydronium, there's this concentration. That means it's going to- Right, so there's gonna be other, like, what if, like, we said you add like a base, right? Let's say one drop of like ammonia acid, right? That ammonia is reacting with hydronium, you decrease the concentration, right? So there's a lot of different things, or like, let's say I'm adding sodium fluoride, right? If I add sodium fluoride, I'm increasing that concentration of fluoride. Yeah, so there's like different applications.
Okay.
Yeah. Yeah. It's going to be on the part on your back. It's killing.
Yeah, it's not always like minus x, it's not plus x, like it could be like minus x or plus x.
Yeah, it could be, but for these kind of questions, it's never like that, unless they give you like a concentration of plus. Yeah, if you have to find Q, but with these questions, because they give you the initial amounts, Q is always gonna be 0 because the products are always 0 times 0. Right, so that's like the.
So for these ones, if you assume that, like one of the products is that concentration, then the other product.
Yeah. So, yeah, so let's say hypothetically, right? But yeah, they wouldn't really ask a question like that. Like, they would have to like be specific about like, oh yeah, like, but then even that, no, you can't assume that because, let's say hypothetically, before you added like this base, you had a pH of like, I don't know, 2, right? pH of 2 before you added this base. You're not at that level yet, actually, because you're gonna talk about that more in part 2, actually. But yeah, They're not gonna give you these kind of questions, yeah, you don't need to expect it right now. Right, you're gonna have like acid base. Like, you're gonna talk about it later, okay? That's what I'm trying to say. They're gonna talk about it later. Like, you're gonna create like buffers, right? Buffers will have like some of the like conjugate base and the acid like in it, and you have to like figure that out, I guess. It's going to be straightforward, that's what I'm trying to say. It's not as complicated, or there's not going to be like other examples you can't think of.
Wait, for this one, I'm assuming there's no ice shard.
No, there's still size.
So for this one, you know that one of these has this configuration, like do you,
Oh,
like that's,
oh, I see what you're doing. Oh,
you assume that, no, right?
no, this is okay.
Is
Okay.
it- is this a?
Wait, so, okay, a conjugate base, right,
Yeah.
always has to produce hydroxyl.
Uh,
Okay, so you wanna make sure your reaction is producing hydroxyl. Okay,
I don't know, it's not.
yeah, not hydro, right? I see what you're, so, like, she did it right.
Simply the acid with its conjugate base. Do you want to produce hydrogen? Yeah, right?
Yeah, like when you have an acid, but when you just have a base, like a base alone, right, is not like. It's not technically reacting with hydrogen, right? A base alone is reacting with the water that's in this thing, right? There's no hydrogen produced. And that water is producing some hydroxide, right?
Yes.
Okay, wait, let me, like,
I don't know.
like you see this reaction. It's like that.
This is like that.
Or, yeah, like this question, right? Because you only have the base, right? And the conjugate base is a weak base, right? So if the base is reacting with water, that's what it's producing. You can't have this reaction happening because there's not a lot of the acid there initially.
Oh, 'cause,
Like there's no 0.650 hydronium.
so you can't just.
Yeah.
So
So-
this is not the right equation.
Yeah, it's not the right
So
reaction
you can start with base.
Yeah.
So how would you know?
because it says that the initial concentration of the conjugate base in a solution is 0. Like
So you shouldn't.
Yeah, like if you have like, if you know what the initial thing is, depending on if it's an acid or base, that's what
You
should
should
have
probably
the
write it
reaction.
in yeah.
Yeah, it depends. Yeah, sorry, I didn't understand the question. It's a good question. No, you're right. Alright, maybe, so. Yeah, oh, that's right, yeah, you're right. Yeah, it's a little bit confusing, but, you're right. That's one way to do. I'm glad that I feel like I'm like catching a break. Good, no, this is good because these are the kind of questions that like, they're not that difficult, but if you don't know how to approach it, that's, you're gonna get such a.
Oh, so now you can convert it to your.
Yeah, so that's why it's like, it's, yeah, if you know it, you know it, and then, so it's not that bad, it's just you have to know how to approach it. Yeah, you can assume that's 25 degrees. Yeah,
Maybe KB. KB plus K.
there's that. Oh, there's something I can.
It's either that or most probably, but.
What do you mean? Mine's worse. You think yours is worse? Mine's terrible. You know, I was in lab yesterday and we had our lab midterm or practical or whatever, right? And then my black teacher looks at my paper, she's like, this is like chicken scratch. This is so bad. He says they're outside in front of the whole class, and I'm like, oh god.
My English teacher, she said my handwriting is the worst she's ever seen in 10 years.
It's not good, bro. It's not good, man. It's not good. That's what I like to do. That's what I'd like to be. That'd be one of the last questions we do, but we didn't get to like. They saw it. I'm good, how are you? Mr. Roy. I feel like when you ask me that, like we've seen each other like
No,
quite frequently, so
it's been like a week now.
yeah, it's
But
spring
it's-
break.
Oh yeah, that's true. Yeah, I have 2 weeks. Yeah, just a really job.
I know, I heard. How was it? No, no,
It was no, it was great.
Well, I usually.
I mean, it was Mateo's birthday, but it's fine.
Would you like to sit down?
Yeah, I'll sit.
Okay, I will
No.
We're in the acid base chapter, so I'm not going to focus so much on MCAT stuff. I mean, like,
No, that's fine. No, during this session, I just pulled up this is like 10 minutes ago.
all right, you guys want me to go over it? Okay.
Sure. Okay. I'm gonna go over it. So, like when it comes to these kind of questions, now that you guys know how to approach it, like next time you see these kind of questions, it's important to like remember how to approach it. Whenever you have just like a base in a solution alone, that base is reacting with water. There's no like, I guess like initial hydronium concentration there. I think like when you try to assume or make your own rules, that's like also when like you can go wrong, especially on the test. But this is like how you should do it, right? So let's say you have a base. You could represent it however you'd like. I'm gonna represent it as A minus because that's easier to represent. Plus H2O, right? And it's producing hydroxide and the conjugate acid, right? Or I'm gonna keep it as all right. So now it's just similar to the last question we've done, right? Where instead of doing a weak acid, it's a weak base, right? And that's not like anything special. It's because they're both weak that like they have the same kind of approach. So 6.05, 0.65, what am I saying? This is nothing, 0, 0, right? Because it's initial concentration. So then minus X plus X, X, right? X, 0.650 minus X. And so what we need to do as well is we need to figure out KB. And so KB, so I believe we have to know this formula, Ka times Kb equals Kw. So Kw over Ka equals Kb. And when you put it in the calculator, it's 1.0 times 10 to the negative 14 over 1.2 times 10 to the negative 4. This is some number, 1.0 times 10 to the negative 14 divided by 1.2 times 10 to the negative 4. Okay, this is 8.33 times 10 to the negative 11. All right, sounds good. So that's the KB. Now we just have to do what we normally do, right? Times 10 to the negative 11 equals x squared over 0.650. Yikes. 0.650. Yikes, I need to have more room for this. 0.650 minus x, and then you put it into the calculator. So y1 is equal to x squared, y2 is equal to blah, blah, blah. Okay. And then, yeah, you put it all in the calculator and then you should do that. So as you guys keep practicing, right, these kind of questions shouldn't take that long, right? Because they're all like similar kind of questions, basically, where it's just the ice chart and then you have to solve. And then after you figure out x, you can do negative log of x. And that will give you the hydroxide concentration or the POH. So you have to do 14 minus the negative log of x. So just keep that in mind, and then that's what you should do for the answer. All right, any questions about that setup? All right, so this is all the answers, right? I put negative log of the x value in there, minus 14, and that's what I got. All right, you guys chilling with that? Good, good. And so this is like also a way to gauge this, like if you have the Ka, you can also know the relative strength of the K, like of the conjugate base, right? And likewise, if you have the Kb, you can find the relative strength of the conjugate acid. And so here's like some thoughts, I guess. Like ammonia, right? This is the conjugate base of ammonium. So they're like directly related, right? You see that this is 10 to the negative 4, this is 10 to the negative 10. So you can multiply those two, it's 10 to the negative 14. And so, yeah, this is just really, you don't need to memorize this, like these numbers or anything, but just have this like understanding that like if you have a strong conjugate acid, you're probably gonna have a weaker conjugate base. That's why like HCl, Cl minus is not even on here because HCl, like Cl minus is like such a weak Kb in comparison to HCl. But something like hydrochlorous acid, right? There's a stronger conjugate base in comparison to the conjugate acid. Or yeah, right? Good. I need to delete this. Thanks. I don't know why I have all that. I think I was doing some problem last year and I forgot to erase it. Do. How would you have it? How would you do this without? Oh, which of the font? Oh, okay, my bad. All right, we can spend 30 seconds on this, I guess, but yeah. So this could be a multiple choice question, right? Where they ask you like which one is whatever, and you might be confused because I've been telling you you need to have a K or KB. But if there's one answer choice that definitely that you can answer it, right? So yeah, for this case, it would be HF, and that's because you have the weakest acid. So the weaker the acid, the stronger the conjugate base. All right, these are relationships I'm telling you, right? The stronger the base, the weaker the acid, the conjugate acid. The weaker the base, the stronger the conjugate acid. Okay, so that's why ammonium and ammonia are very interesting. There we go. So. Yeah, we can try this question too. There's a lot of questions that you guys are doing. I think after this, I think this might be it. They're not gonna have like the big one. Maybe a lot of people. You might have the accent instead of tape, that's like unlikely though. You're not gonna have the accent unless you understand. Great about that. Maybe like something. And I have to be very.
Yeah, absolutely.
You already assumed that the acid.
Yeah. Yeah, I got a lot. I think it's been July 31st. It's messed up what happened with me. 2 months of my 16 days.
Oh, yeah, you want the para.
It's not that bad.
You know,
It's not that bad.
like para has like Canadian accent, so.
Yeah,
it's
it's
like,
nice.
it's like what,
Yeah, it's not that bad, but I was surprised because it's audit and then I did back to it.
yeah, you just, I know which ones.
Yeah, you just gotta memorize it.
So every, there's a chart, there's like a chart behind them.
I don't think there's a chart on here.
It's not a chart. It's only- Like, it's only all the directions.
I mean, you should split it up right now. So we can start with, strong ones are here, like, maybe this guy, yeah. Maybe they have here, but so.
Yeah, no, he'll be just like laying.
It confused. It's not like that. No, Burrito has like a wide, it's like an online test, yeah. OBS via. Yeah, like, it's, that's not bad. We used to use this wide online. I mean, it is intense.
Yeah.
It's not very. Mostly, you'll probably like more about my.
Okay.
Yeah, I didn't like it. Yeah, it was bad, but I like it a little bit. I still like it. It looks like. I said that when it's.
Was it on that?
No, I just don't like it.
Okay.
Yeah, yeah, it's just famous. I mean, for us, it's easy. We have like a guy from the city and he's just, he's giving us the names. I'm not complaining, but, he's one of
Yeah.
for 2 semesters, I haven't had any physics, so, I mean, I'm just so steady. I have like what, 4 months? Yeah. Because our last one was by May 18th. The fun. Oh, okay. May 31st is cool.
Yeah.
You know the venue? Yeah. I was thinking like June, well, it's pretty early. My fault on the. I. Like, it's a semester. Barely.
My bad. Let's see this. How did I do this? I made the thing, but. What? Oh, what? Oh, okay. All right. Yeah.
Yes, yeah. So you're gonna there's something, we'll do this. Yeah.
I don't know, the finals. No, the finals. Yeah. But it's
Yeah.
not. It's like,
Something like.
it's like lawsuits.
And so, right, and it's very, like, honestly, even not going about hydroxide.
Oh, yeah,
So that's why the bronze are very
Yeah.
base, but leukemia is.
His exam, this is
Right,
fine.
it's like nothing. It's absolutely.
In the sense that like,
You
you
need
need
to
to
make
make
some, like, using hydroxide, that's gonna be a direct, it's like, because the hydroxide is actually have a, like,
it's like
a
conceptually,
and it's also reducing
concepts are so good. It's like the new,
Right, so,
topic now.
yeah, so.
That's not really
I don't know, it's like at least I think with like.
Oh, it didn't. It's not really the right option.
I don't think there's, you'll be fine, you'll be this.
That's the gates.
The others, yeah. You
What
like
is
to
it?
have in the lab, like a small one.
Yeah. Alright, you guys want me to go over this question?
Yeah. So with this kind of question, I should have realized this originally because, yeah, I did not look over it, but when you're given the pH of something, right, that's the like concentration after equilibrium, all right? And so obviously a base is not producing hydronium, but you can figure out the hydroxide concentration because pH is equal to POH, or pH plus POH equals 14, right? And so from there, you can figure out the concentration of the hydroxide, right? And you can also figure out the concentration of the conjugate acid, right? And so in this case, it would be 14 minus 9.89. So that's some number. 10 to the, yes, 10 to the, or 14 minus 9.89. That's 4.11. So you do 10 to the negative 4.11. Yeah, so 10 to the negative 4.11 gives you 7.76 times 10 to the negative 5. This equals the concentration of hydroxide at equilibrium and also the concentration of HA at equilibrium. And so from those different units, we have the initial amounts. And yeah, the initial amount would be, if you look here, right? You see here that, yeah, this is like very negligible as well. That's why I also didn't subtract it. So obviously there's some subtraction happening here because of how negligible this value is in comparison to this. I kind of disregarded it. You can include it if you would like, but it's not really going to change your answer that much. And so you can just simply put these two things here and then figure out the KB from there. And then from the KB, you can figure out the KA. If that makes sense. So again, right, you could subtract this by 7.76 times 10 to the negative 5, but it's very negligible. So it's really up to you if you want to do that. But yeah, does that make sense? Okie dokie. Did we talk about this in class? We didn't. Did we talk about? We didn't get up to here. Okay. So yeah, that's pretty much all I'm gonna go over. I'm gonna turn off the recording. Boop. All right. Hopefully that records. All right. Yeah, do you guys have any last minute questions or comments, concerns or anything? Listen, guys, all right? Study smart, okay? You guys have things for anatomy, all right? Wait, okay? So with that being said, I don't, try to make sure you study topics that you guys need to study. Study smart, study hard. Don't study too hard, but study smart. That's the whole thing. Okay? You guys. I'll be here if you guys have any questions. If you want me to go over like any of the equilibrium